So we know very little about deep sea. However, the deep sea really gives us the best archive of past climates and past environment.
Most people think of science as happening in a laboratory in a very controlled environment, and one of the things that is really amazing to me about the ocean drilling program is that we're still in a discovery mode.
There are layers of individual sediment deposits, and each layer is almost like the page of a history book, because each layer gets deposited over time, and we can drill into these sediments to reconstruct, just like a historian or like a detective, what the situations were on Earth in the past.
And this history is linked to climate change, it's linked to the mantle convection, and it's quite important in order for us to understand the future of mankind.
The unique thing about IODP is it's a truly international science community. It's one of the only examples where people from many different countries are participating as complete collaborators.
And so all major countries are contributing financially and scientifically to this program.
This is a unique program in the scientific community, earth science, but also the biological community and the physical oceanography community, because it's the only program that really drills sediments below the surface of the seafloor.
This program is really the space program of the earth sciences, of geology and the associated earth system science.
INVEST is going to be the foundation of the new science plan for the future drilling program.
The purpose of this INVEST workshop is really to understand where we are now with ocean drilling and identify the most important questions for the next 10 years after, 2013.
The way the drilling program has always worked is that the science plan really comes out of the community.
So it's a huge range of scientific disciplines and also international backgrounds.
Almost 600 people that decided to have their word in a sort of democratic way to decide what the main priorities of this program are.
And I think a special thing is also that maybe half of the people are young people, young postdocs, and also some PhD students. So it's a good mixture between experienced people who were involved in the program in the last decades, and then the new generation which has to shoulder the new program.
We have to decide on something that is really, really expensive. It's going to take a lot of funding, and we have to decide how to move forward and how to use the funds in the best way. And so I think it's important that everybody gets the opportunity to comment and say what they think is the direction we need to go.
The heart of this conference is actually those working groups that are going to define our goals for the next 10 years.
A very large component is one of climatic change in the past and presumably for the future, but also other aspects like tectonics, earthquakes, hazards to human life, sea level change, many things that really affect the society that we're trying to support.
In order to predict our future, I mean, like global warming, as accurately as possible, the only way you can do is to recreate what has occurred in the past, because future you don't really know.
There's one quote by Jim Zakos yesterday who said that for ocean drilling, discovering how climate change worked in the past is not an option, it's an obligation.
We show that the climate has been a lot warmer in the past. Immediately, people recognize the fact that the climate can change. Okay, so that's a starting point.
There's a new important development with the Japanese drill ship, which is called Chikyu, or Earth. And that drill ship has new technology that actually allows the drilling very deep into hard and solid rock.
Right now, Chikyu is engaged in drilling into the seismic fault. And this fault is capable of generating magnitude 8 earthquakes, so very large. And this earthquake is statistically expected to occur within a few decades' time.
Well, what I'd like to see come out of INVEST is that we really can identify some of those key targets that I would call grand challenges for our science, the really big-scale problems that need a long-term approach, international collaborative approach in order to address them. So if this workshop can identify what the most important of those grand challenges are, then I think we've really done our job.